So there are so many things that a basketball coach would look for in a player: height, weight, how you dribble the ball, how fast you move, can you stop suddenly, and how long your arms are, how long your legs are. There are so many factors. Maybe the food you eat in the morning, maybe the kind of multivitamins you take every day. There are so many factors that could matter when you look at the high scorers and high performers in a team. What should you look at? How do you figure out, among the 10 million things that could be relevant, what matters most? So that is the technique called principal component analysis, where you take the data in one space and linearly transform it into a different space, and then you look at what we call the principal eigenvectors, or the primary vectors in a different space pertaining to the largest eigenvalues or the largest components, and you look to see what are the elements out there. The data that is transformed into a different space, and you find that you reduce the dimensionality by figuring out that most of the variance in the data is explained by a fewer number of elements that are linear combinations of the original variables. So you have variables in one space, you linearly transform them into a different space, and you look to see how the variance and the variability in the data is explained by a fewer number of transformed components. That's what we call reducing the dimensionality of the data. Well, in factor analysis, you take a closer look at the principal components and then look to see what are the big ones out there, and ask, are they the big factors that explain performance, that explain variability? So if you are an HR person and you look at employees and you say, my God, if I look at all my high performers and my low performers, and I ask myself, is it education? Is it the years of experience? Is it a personality test? Is it the amount of incentives they have? What is it that really makes, what are the factors that contribute to a high performance employee? Is another variation of factor analysis. So you quickly realize that a lot of the garden variety problems we wrestle with, not knowing what matters most, whether you are a physician looking at a patient, a parent looking at a child's performance, an HR exec looking at employees in a company, or a product manager looking at a product performance, or an advertising executive looking at the multi-factors that are responsible for the success of a social media campaign. You want to reduce the dimensions, and principal component analysis and factor analysis give you an opportunity to reduce the dimensions. Once you reduce the dimensions and you understand what truly explains the variance and variability in the data, it naturally leads you to optimize. So you only focus on that which matters the most. So optimization is another fancy way of saying, is there a way to bet resources or whatever functionals you have and initiatives you have on the fewer number of things? And through a combination of PCA, or principal component analysis, and factor analysis, you understand what matters most, and you automatically fine-tune your betting strategy or your resource allocation strategy to maximize the output you want, and that leads to optimization. These become very powerful tools in the world of machine learning as you apply them to the real-world problems of marketing, product development, product pricing, and even in a company, understanding your employees a little better and finding out what motivates them the most.